In this video, you will learn a few ways of doing quantitative chemical analysis. There are two popular ways. One is called titration, the other one is gravimetric analysis. Titration is about how you analyze an acid or base by doing the neutralization experiment. You will learn more about the titration in Chemistry 2. That's the next semester of your chemistry sequence. So let's talk about gravimetric analysis now. Gravimetric analysis is by converting the chemical that you want to analyze into the other form. Let me give you an example. Let's say now you have a solution, okay, in a big beaker, and you know that that is, let's say it is silver nitrate dissolved in water, aqueous silver nitrate solution. And you want to know the concentration of the silver nitrate in this solution. How can we do that? Okay, so we can take a small amount out. Okay, not the whole thing. We can sacrifice a small amount. And the point is, we want to do some treatment that to make it to change its physical state or have another chemical form. Okay, so what I can do is, for example, I can get 50 ml out from this big flask, and now I add table salt in it, sodium chloride. Okay, so now I know it's 50 ml. I put salt in it. What will happen is the silver ion that is in the silver nitrate solution, because silver nitrate is soluble. And when you add salt in it, it will plus Cl minus, it will form a solid. It will precipitate out the silver chloride. This is a solid. It's not soluble. So after I add excess amount of salt in it, I can get the white crystal. And what I can do is, I can filter out the white crystal, dry it, and measure the weight. And from there, we can calculate and see how much silver ion is in this 50 ml of solution. And therefore, we know the concentration of silver in the big reservoir solution. Okay, well, that is just one example. And very often, we do a combustion analysis, especially on hydrocarbon compounds. Okay, so what is that about? Combustion. Let's talk about combustion. Combustion, especially combustion of hydrocarbons, it is a combination. Let's say you have a hydrocarbon. Hydrocarbon will be hydrocarbon. We don't know what happened here, so we don't know the ratio. If you burn it with oxygen, with enough oxygen, with excess amount of oxygen, what you will get is, you will get carbon dioxide and water. So this is a combustion reaction of hydrocarbon. Okay, what happens if you don't have enough oxygen? Oh, well, let me give you an example. In your stove that you use at home to cook, methane will be coming out. We are burning methane. And if you add oxygen, supposedly it's going to yield carbon dioxide and water. This is a complete combustion. What happened is not complete. That means for some reasons you spray water on the fire, or there's not enough oxygen in the kitchen. So that is called the incomplete combustion. What happened is you have an additional product over here, and that is CO. That's carbon monoxide. So when you have an incomplete combustion of the methane gas in your house, you're going to produce carbon monoxide. And how do we know that? When it is a complete combustion, you will see that the flame is blue. If there's an incomplete combustion, you can see the flame is orange or yellow. So when you look at it, if there's color other than blue in the flame, that means you are having an incomplete combustion. So be careful. That's why people would like to put a carbon monoxide detector in the kitchen or in their boiling room in the basement, because just in case of incomplete combustion. Okay. Let's look at another example of how we analyze by using combustion reaction. And by the way, here is the diagram of showing how to do this. So you have a sample. Let's say we have a sample, hydrocarbon sample over here. And first we need to burn it, and it will become in the excess amount of oxygen. Then what we have is CO2 and H2O. That will be the product. And then we can analyze it. And by the way, ASTM 6866, ASTM stands for American Standard Testing Methodology. So this method actually it starts exactly this step. And by the way, this one is to analyze, ASTM 6866 is to analyze how much is a bio-based carbon. For example, nowadays people try to minimize the use of petroleum, and therefore they would prefer the product to be bio-based. That means it's renewable. For example, if a piece of plastic it can make from corn, then it would be better than the plastic that is made from petroleum. But how do we know that the plastic is made from corn? We look at the ratio of carbon-14 to carbon-12. If the carbon is very new, that means if it's made from bio-based, then that will contain more of the carbon-14. If it's made from a petroleum resource, that will have less amount of carbon-14. And how they do it? The first step is they're going to put that plastic into a chamber and heat it up with excess amount of oxygen. What will be produced will be carbon dioxide and water. And then we can analyze the carbon dioxide, because carbon dioxide is easier to analyze than something in a solid form. Okay, let's look at an example for calculating it. Okay, so let's look at this. Polyethylene is a hydrocarbon polymer used to produce food storage bags and many other flexible plastic items. A combustion analysis of, okay, let's write this down, 0.00126 gram of the polyethylene. So over here, we don't know what the formula is, but we know that it's hydrocarbon. That means it only contains hydrogen and carbon. Okay, so we start with 0.00126 gram and react with the excess amount of oxygen. Okay, let's see what we get. We get 0.00394 grams of carbon dioxide. Okay, and what we want to do is we want to determine the empirical formula of polyethylene. Okay, so what is that important? For example, how do we know that plastic is polyethylene? Or why not is polystyrene? Because polyethylene will have a different empirical formula than the polystyrene and will be different from polycarbonate or a nylon or other plastics. Okay, usually the polyolefin will have the same empirical formula. For example, polyethylene and polypropylene, they will have the same empirical formula. Okay, regardless of what type of plastic it is, let's see how we can determine the ratio over here. Okay, when we do the analysis, in this case, we have to assume that it is 100% yield. The percent yield will be 100%, so 100% yield. That means let's come back here. In this experiment over here, whatever sample we have, if it disappears from here, it must be over here. Okay, so that is the assumption. As compared with the previous lecture, where we see that the percent yield will be less than 100% because we have made error somewhere. But in this case, when we try to analyze the percentage or the ingredient, we have to assume that it is 100% yield. Okay, let's do it. As for carbon dioxide, okay, so let's see how many moles do we have here. So let's try here. So it will be times per mole, how many grams? Okay, so the molecular weight is 44.01 gram per mole. So this will be the number of moles of carbon dioxide. I used my calculator. What I get is, it turned out to be 8.95 times 10 to the negative mole. That many mole of carbon dioxide. It is the same number of moles for carbon atom. Why? Because one carbon dioxide molecule will contain one carbon atom. Let's do the similar thing for this part over here. Oh, this part we cannot do. So how do we do the other parts? We need this part over here. Okay, so let's look at this part over here. Water. It says it's used that much of water, so 0.00161 gram of water. I have to turn that into how many moles, so I'm going to divide by the molecular weight, and that it is 18.02 grams per mole. When I do that, what I find out is 1.79 times 10 to the negative 4 mole. And that, well, for comparison, I'm going to move it a little bit so they have the same magnitude here. So this one, it is 17.9 times 10 to the negative 5. It is equivalent because I want to make it to 10 to the negative 5. So what I'm going to do is, I am going to see what the formula is. Okay, so when I look at over here is, so this one is about 9, this one is about 18, so the ratio is 1 to 2. Okay, so in this case, I know that it will be C1H2. That is the empirical formula, or we can just say CH2. Okay, so in this case, we don't even need to worry about the percent yield because we are going to catch everything here. And based on the product, we can calculate the ratio already.